Okay, so today we're going to be graphing systems of linear inequalities and using those graphs to determine solutions. We'll also determine solutions algebraically. All right, so let's get started. All right, so we're going to tell whether each ordered pair is a solution of the system of linear inequalities. Here's my system. Y is less than 2x. Y is greater than or equal to x plus 1. I'm going to start off by showing algebraically whether or not 3, 5 is a solution. And then we'll look at negative 2, 0 being a solution, and then we'll graph and show using the graph as well. So you'll have two different ways that you'll be able to determine whether or not a point is a solution to this system. All right, so we start off with y is less than 2x, and since the 3 is x, 5 is y, we replace, so we get 5 is less than 2 times 3, which says 5 is less than 6, which is true. Then we take our second inequality, y is greater than or equal to x plus 1, replacing y with 5, x with 3, and we get that 5 is greater than or equal to 4, which is true. Since both are true, 3, 5 is a solution. Okay, similarly we can do that with negative 2 and 0. So for our first inequality, y is less than 2x, we'll say 0 is less than 2 times negative 2, which is 0 is less than negative 4. This is false. We check the other inequality, 0 is greater than or equal to negative 2 plus 1, we get 0 is greater than or equal to negative 1, which happens to be true. However, because of this one false, this point is not a solution. It has to be true for both to be a solution. Okay, how would that look on a graph? Okay, so we'll take our two inequalities and we'll graph them. Y is less than 2x. We would start at 0. We have a slope of 2 over 1, so rise 2 to the right 1, and then down 2 to the left 1. Give me a little more graph. There we go. Okay. And then because it's strictly less than, we would have a dashed line through the points. Okay. All right, and less than means we'll shade down from the lines because this is where our line points are less than. I'm just going to give it a little bit to help myself know that that's the direction I'm shading, because now I have to take the other inequality into account. Okay, so our other inequality was y is greater than or equal to x plus 1, so we start at 1. Our slope is also 1, so we rise 1 to the right 1, or we go down 1 to the left 1. So it would be fall. If I'm going to rise, I fall. Okay. Okay, and that was greater than or equal to, so that's a solid line this time. Okay. And then my shading should be above, because that's where the numbers are greater. But over here is not going to be part of my graph, because I've already determined that this is the direction that we'd be shading for the other line. So my solution is what they have in common. So I only need to shade here because that's where it's greater than the second inequality and less than the first. Okay? So this is actually my solution. If you want to, you can go ahead and erase these other little lines down here so that you're not confused by them later on. Okay? All right. So now we want to graph our points and see where they lie. So 3 up 5 is right there in that red. So we can see that's a solution. Okay. When we look at -2, 0, it's way over here. So it's not a solution. It's not in the shaded area at all. Okay. Now, something that's not part of this particular problem, but I just want to point out, this would be a solution on the solid line, but a point on the dashed line is not a solution. Or even up here, even though it's next to the shaded, not a solution. Okay? So the solid lines and the shaded area are where our solutions are. Anything else would not be a solution. Okay, let's look at another problem. Name an ordered pair that is a solution of the system of linear inequalities. Okay? We have a lot of space to choose from. This would be a solution. This would be a solution. Over here's a solution. Lots and lots of solutions. So you just need to pick one that you want to talk about. So I'm going to say -1, -1 here would be an ordered pair that is a solution, and then is not a solution. Again, got a lot of choices. Just going to come out here, and at 4, 4, that is not a solution. Okay. Okay, so when we're graphing, you can see here what they did is they shaded in pink for one line, and they shaded in light blue for the other, and where the two crossed, you kind of get this purple area. So when you graph them, you want to find the intersection of the half plane, so that's that shaded area. Okay. All right. Graph the system of linear inequalities. So this is just straight graph it. So y is less than or equal to 3. That means we're going to 3 on the y-axis, and it's going to be a horizontal line through this point, and it's less than or equal to, so it's going to be a solid line. Okay, so 1, 2, 3. Okay, and there's our solid line. And we know that it's less than, so we're going to be shading down from that point. So I'm just going to give myself a direction to go in. We're going to be shading down. Okay. And then y is greater than x plus 2. So we'd start here at +2. Rise 1, go to the right 1, because our slope is 1. Our symbol is strictly greater than, so we're going to have a dashed line. All right, and it's greater than, so we're going to be shading above this line. Okay, but I know it's not going to be over here that I'm actually going to need the shading, because I already know that I'm going to be shading down from that blue line. So above the red line, but below the blue, is just in this area here. Okay. All right. So that's our graph. Graph this system. Okay, now this is written in standard form, so we're going to have to put it in slope-intercept form. So we'll subtract the 2x. Just going to put a little line there. Subtract the 2x, and y is less than -1 minus 2x. So we go to -1. We have a negative slope, so we rise 2 and to the left 1, or we fall 2 and to the right 1. It's strictly less than, so it's a dashed line. Okay. Our shading will be below. I'm just going to remind myself to go below the line. Okay, and then we graph our second line. So 2x plus y is greater than 3. Subtract the 2x. Y is greater than 3 minus 2x. We begin at 3, and we fall to the right one. Or rise to and to the left one. Okay. This will also be a dashed line. And we're greater than this line. Okay. So we're shading that way, which means that our two lines don't actually have an overlapping, so this would be no solution. There's not going to be any point that works. Okay. All right. Write a system of linear inequalities represented by this graph. Okay, so going the opposite direction. So I'm going to start here. I'm going to call this A and this one B, just so to write them. So A, I look, it's a dashed line, so I immediately know my inequality symbols, or it's going to be one of those two. We're shading below the line, so the numbers are getting less, so I'm going to use this inequality symbol. Okay. So I'm going to write it in the form y equals mx plus b, the slope-intercept form, so I need to know what m is. So I look over here, and from point to point, I seem to be rising 1 and running 1. So my slope is 1, and my y-intercept is right here. It's where we're crossing the y-axis, which is 0. So I put that together, and I get y is less than 1x plus 0, which simplifies to y is less than x. Okay. Now the other equation, or other line, is horizontal, so I know that means m is 0. And it's solid, so I know I should use one of these two inequality symbols. And I'm shading above that line, so that means it's going to be greater than or equal to. And then it's the y-intercept is here at -2, so b equals -2. So I put that together, and I have y is greater than or equal to 0x minus 2, or more simply, y is greater than or equal to -2. Those are my two inequalities for this system. Write a system of linear inequalities represented by the graph. Okay, so same idea. I'm going to call this one A and this one B. Okay. This is a vertical line, so I remember those are my special cases where there is no y, it's simply x equals, and x equals the number where it's going through the x-axis, so that's right here at 3, so x equals 3, but I don't want to use the equal sign because I want an inequality. So I look, it's a solid line, so I know it should be less than or equal to or greater than or equal to. And the shading is happening to the left where the numbers are less, so I want to use less than or equal to. So my final answer here would be x is less than or equal to 3. Then I look at B, my B line. All right, now it is diagonal, so I know it has a slope to it other than 0. It's going through the y-axis here at -1. Let's see. Trying to get my slope here. Seems to be going through an integer point in here. So down 1, 2 over 1, 2, 3. So that would be a 2/3 slope. So M is 2/3. B is -1. And then my inequality, it's dashed. It's got to be less or greater. And then because I am shading above the line, that's where the numbers are greater. Okay. So putting that together, y is greater than 2/3 x minus 1. Okay. You have at most 8 hours to spend at the mall and at the beach. You want to spend at least 2 hours at the mall and more than 4 hours at the beach. Write and graph a system that represents the situation. How much time can you spend at each location? Okay, so we have the mall time, and we have beach time. Okay. Since the graph I've got here has X and Y on it, I'm just going to decide for mall to be X and beach to be Y. Okay. And then I have at most 8 hours to spend. So I know that my mall time and my beach time has got to be less than or equal to 8. Because at most 8 hours. Can't go over that. All right, and then I want to spend at least 2 hours at the mall and more than 4 hours at the beach. Okay, so I want my Y to be, no, the mall was X. Okay, so I want my beach time to be greater than or equal to 2. And I want 4 hours, more than 4 hours at the beach, so Y should be greater than 4. Okay, I think that takes care of all the conditions they've put on me. All right, so X is greater than or equal to 2 would be a vertical line here at 2. It's going to be solid because it's greater than or equal to. And my shading will be to the right because that's where it's greater than. Okay, and then Y is greater than 4, so that's a horizontal line here at 4. Keep the colors, okay. And this time it'll be a dash line because it's strictly greater than. Okay, and we'll be shading, let's see, greater than, we'll be shading above. So I know it's just going to be in this section now, right? Okay, and then X plus Y has to be less than or equal to 8. Okay, so we need to solve that for Y. So I will subtract my X from both sides, and I know that Y needs to be less than or equal to 8 minus X. So we begin at 8, which is slightly off my grid here. Okay, probably should change colors there. And then we will decrease 1 at a time, so we'd be at 0, 8, then 1, 7, which would put us at 2, 6. And so we're coming through here. Okay, and it would also be a solid line. So our solution is just that tiny triangle here. As we rise here, these are possibilities. So we could spend between 2 hours and 4 hours at the mall, and that's solid. So that's included. So our mall time, we could go from 2 to 4. But that's somewhere, any number from 2 to 4 would be good for the mall. And then the beach, look at for the beach, we could go from 4, well, just above 4, because we said we wanted to be more than 4, right, in that dashed line. Okay, so we can go from 4 up to 6, but we can't do more than that. So at the beach, we can go between 4 and 6 hours. Okay. All right, so now you need to get to work on solving linear inequalities by graphing.